You're watching my channel Spark Virtual Academy, and in today's lecture we are going to learn about the resolution of vectors. That is the topic of physics again. So we are going to learn the physics. Now this topic, that is the resolution of the vectors into the rectangular components, is present in both the classes, the class of ninth as well as the class of metric. Okay. So before going towards the resolution of vectors, as I told you that we should be very well aware of the trigonometric ratios before learning this topic. About the trigonometric ratios, we should understand the three basic ratios, which are the sine theta, the cosine theta, and tangent theta. Now, sine theta, it is always equal to perpendicular upon hypotenuse. Cosine theta is always equal to base upon hypotenuse, and tangent is always equal to perpendicular upon base. Now you should memorize these three trigonometric ratios very clearly, and I have already discussed about in the lecture of the trigonometry about these perpendicular, hypotenuse, base, and all these in the lecture. You can just go into my channel and watch that video as well. Okay, so coming back towards the resolution of vectors, let's suppose we have a vector that is given like this. Now this is your x-axis and that is your y-axis, and suppose I'm just changing the marker. Suppose this is a vector A which is given. Now we have to resolve this vector into its rectangular components. Now by rectangular components we mean the four factors that we have to determine. Number one factor is the distance that this vector has traveled in the x-axis. So we can say up to here that is the x component of this vector A. Similarly, the second factor from this origin is the distance which is traveled by this vector in the y direction. Now we can say that this is the y component of this vector A. That is the second number thing that we have to determine. The third number thing is the magnitude of this vector. Means we have to determine the magnitude of this vector as well. And the last thing is the angle which is made by this vector at the origin, at the center. Now this angle is made with respect to the x-axis because this vector is starting from this origin which is related to the x-axis, so we have to determine this angle as well. Now this angle means the direction. Now by this angle we mean the direction of this vector, whether it is going anti-clockwise or it is going clockwise. It means we have to determine, in resolution of vectors we have to determine four things. Those are the x component of the vector. Now whatever the vector is doesn't matter, the x component is there, the y component is there, magnitude of vector is there, and direction of the vector is there. Now direction means the angle. Okay, so we have to determine these four things. X component means, here x component means ax, y component means ay, magnitude means mod of a, and direction means the angle which is met at the center of the circle. Okay, now we should understand that whenever the question is there, you have to resolve the vector into its rectangular component, then you have to determine four equations. Okay, you can see there the distance from origin to this point, that is ay, and this distance is similar almost. So we are just going to join this and we are just giving it the same name, that is ay. Now you can see there is a complete triangle that is made at the center. We can just make this triangle separate like this. If we just make it separate, or comparing to this, here is theta, this distance is ay, this is your a, and this is your x. Here you can see here the perpendicular line is there, so the angle is 90 degree. Now the opposite side of this 90 degree is always known as the hypotenuse. The opposite side of this angle which is under consideration is always known as the perpendicular, and the remaining side which is the adjacent side is known as the base. So we can note down roughly out of this picture, or this is just a sample, however this is the main picture that you should understand. Okay, so from this picture we got the values of perpendicular as ay, base is ax, and hypotenuse is a. Okay, and by keeping these three sides, one more theorem that I told you in the trigonometry was the Pythagoras theorem. So you should also just recall that as well. The Pythagoras theorem. Okay, that was hypotenuse square is always equal to base square plus perpendicular square. You should just recall these things. So let me just repeat the things again. And resolution of vectors, we have to determine four factors. Those are the x component, the y component, the magnitude of that vector, and the direction or the angle of that vector. So we suppose in the two axes, like the x-axis and y-axis, a vector is given, that is a vector, that red vector, which is making an angle of theta with the horizontal there, and we have just resolved it into its rectangular components. By resolving, we mean the distance that the vector has traveled in x-axis and the distance the vector has traveled in the y-axis. We just suppose that both, and since the distance of this ay is almost same here, so we just put it here to complete this triangle. And by doing that, we just draw the same figure here, the triangle here, and here after drawing we got the values of perpendicular, base, and hypotenuse. Now let's move towards the derivations of these x component, y component, direction, and all these simultaneously. Okay, so first of all we are just going to determine the x component of this vector a. It means we have to determine x component. Now as you can see here in this picture, we have to determine this side, and this vector is given already. It means we have to determine the base, and hypotenuse is given. Now out of these three sides, base, hypotenuse, and perpendicular, we have to use two sides. Out of those two sides, one would be given, and always the hypotenuse is given, as you can see there. And then you have to use the second side, which is to be determined. Okay, so right here in this picture, we have to determine base, and hypotenuse is given. So out of these three trigonometric ratios, if you see there, base and hypotenuse, they both are used in the sign of the cosine. So here we would write down, as we know that base upon hypotenuse is always equal to cos theta. Now we are going to replace the values, since we know that base is equals to ax and hypotenuse is a, and it is equal to cos theta. Now this a is in deviant, when we will just cross multiply it, okay, the x component would be equal to a cos theta. Now that is the formula to determine the x component of any vector when we are resolving it. Okay, so in future, whenever in the next topics, whenever the x component is used, you can just directly mention the x component by this formula, that the magnitude of the vector is always multiplied with the cosine of theta, then you will get the x component of that particular vector which is to be resolved. After the x component, we have to determine the y component now. Now for y component, as you can see there in the picture, perpendicular is to be determined and hypotenuse is given. From the three trigonometric signs, sine theta is always equal to perpendicular upon hypotenuse. So we will use the sine theta. We will write down here as perpendicular upon hypotenuse is equals to sine theta. Now, since perpendicular is equal to ay and hypotenuse is equals to a, so we just put there ay upon a is equals to sine theta. Now, again, similarly, by cross multiplication, we would get the answer for sine theta. Now, that is the formula to determine the y component. So, I'm just writing down the formulas here. Ax was equal to a cos theta and ay is equal to a sine theta. It means whenever you have to determine the y component of any vector which is resolved, then it will always be equal to the multiplication of the magnitude of that vector with the sine of angle of theta. So that is the y component of that vector A. Now, when we have determined the x component and y component, it means two sides are given now, are determined there. Okay, bases are already there, and perpendicular is x component is determined and the y component is determined. Now we have to determine the magnitude of this vector. Now this vector A. So when two sides are given and the third side is to be determined, then we will use the Pythagoras theorem. So we would write down here for magnitude is equals to question mark, and we would use by PT. Now Pythagoras theorem, that is equal to hypotenuse square plus perpendicular square. Now just replace the values. Hypotenuse is equals to a, base is equals to ax, and perpendicular is equals to ay whole square. Now we have to move this square to the other side. Whenever the square is moved towards the other side, it goes on the other side by square root. Okay, or in simple words, we can say that by squaring the both sides. If we just square it, we took the square root of this side, and we are also taking the square or square root of this side as well. Now here, square and square root is cancelled. You just get the magnitude, and that magnitude is equal to the under root of x square plus ay square. For the magnitude, you can put these two lines, these are used for the mod, or you can say that the modulus. Now this mod or modulus means the magnitude of anything which is written in the middle of these two lines. Okay, so now this is the formula to find out the magnitude of this vector. Okay, so I'm just writing down there a is equals to x square plus ay square. The last thing which is remaining is the direction, or we can say that the angle of this vector. Okay, so for the direction means the angle, as you can see there, since this vector is drawn and it is used by, or the direction of this vector is determined by this x-axis and the y-axis. So we are going to use this x-axis and this y-axis together to determine the direction for this given vector. So as you can see there, this is the base and this is the perpendicular. So for direction, we would use perpendicular and base, and since we know that perpendicular upon base is equals to the tangent theta. Now just replace the values of perpendicular. Now perpendicular is ay and base is ax, and it is equal to tangent theta. Okay, since we have to determine this theta and this tangent is not required here, so this theta will be equal to tangent inverse ay upon ax. So now this is the formula to determine the direction of this vector. It is always equal to tangent inverse by angle of ay upon ax. So in short, we determined four formulas. Number one was for x component, and it is equal to a cos theta. Second number one was the y component, and it was equal to a sine theta. The third one was the direction of this vector, which was equal to ax squared plus ay squared and whole of under root. And the last one was about the direction of the theta, and that was equal to tangent inverse ay upon x. Now this was equation number 1, 2, 3, and 4. So whenever you have to resolve the vectors into their rectangular components, make sure that you are drawing this vector correctly, and do not forget to draw this triangle separately to understand the picture clear. It's not mandatory to draw this picture. Without this picture, you can solve directly from this picture. But if you have the complete command on over it, then you can use this. Otherwise, it's better to draw the picture separately and then just drive these four formulas separately. It would be easier. Now, if you have any question regarding this topic, you can put your question into the comment box and I will try to answer your questions. For the handout, you can contact me on my WhatsApp number or on my email, which is connected or which is given in the description box. Do not forget to subscribe and like my channel, and subscribe my channel and press the bell icon for the latest videos to get the latest updates about the latest videos which I'll upload in future. Till the next lecture, bye bye and Allah Hafiz.